We begin with how cubes fill all space. We learned that if you double the size of a cube, you increase its volume by 8. The small cube is 3 tetravolumes. The large cube is 24 TVs. The VE has 20 tetravolumes, so the 4 TV volume left over is divided by 8, so each 1/8 octa is 1/2 TV. You can see that inside the smaller cubes are tetras that construct the triangular faces of the VE. 8 faces, 8 cubes. The 4 self-organizing circles define the VE's relationship with the cube. The 1/8 octa modules construct a cube around the VE. In previous video, we explored the structural memory of this modular unit. If you add a 12BB tetra that shares its center with the 6BB VE, you see that the 1/4 tip of the tetra penetrates outside the VE. This provides increased structural integrity to the octamod. It reinforces the weak faces of the 1/8 octa. These 8 1/4 tips are part of the duotet inside the VE. Here you can see that each cube is a tetra covered with 3 1/8 octamods, with the 4th hidden inside. There's always a same size octa inside a VE whose corners are tangent with the centers of the square faces of the VE. The 50 directions of the sphere family communication network has a symmetrical relationship between systems. Inside any octa is a half-size VE. Here it is easier to see the interconnected relationships of the 50 directions. The 12 white directions define the outside corners of the VE, and that same location defines the midpoints of the octa. The rest of the directions follow a symmetric logic. Using whole systems thinking when studying a new structure means first looking for the connections among the essential parts. How is the center linked to the outside limit? How do the communication networks penetrate through various containment fields, connecting which locations in common? These are the first steps in finding embedded modular building patterns in fundamental structure. By turning the 6 half octas that form the square faces of the 6BB VE inside out, you construct a 12BB octa as its containment field. Whatever the edge of the VE, there is same-edged octa inside and a double-edged octa outside the VE. Here is a duotet with 2 6BB tetras sharing the center and spinning in opposite directions. Where the 2 meet is a half-sized octa. Each face of this octa has a half-sized tetra covering it. The 24 yellow directions define the midpoints of the quarter triangle on the octa face. That is interconnected with the quarter division of the tetra edge. With just one 6BB tetra, the yellow directions are split. 12 at the midpoints of the quarter triangle, and 12 defining the 1/4 divisions of the tetra edge. The blue directions are split as well. 4 passing through the center of the face, and 4 passing through the outside corners. This is helpful in understanding how the tetra, octa, and VE that have a same edge and share a common center fit together into one synergetic whole.